All right, so this is on how light is made from atoms. So to make light with an atom, first you're going to need electrons. So to make an atom, you need electrons, and those electrons can hang out in certain electron shells, as you see here. Here's the first, second, and third shell. Now, those electrons can only go in those shells. They cannot go in between those shells. So let's say we have a little electron right here, and this electron is as low as it wants to be. They always want to be in the inside shells first. Well, if you give this electron a push, you can push it to the outside shells. Now, how this is given a push is with light. So light can actually push an electron. It can push it up one shell, up two shells, up three, four. You get the idea. It can go up multiple shells at a time. Now, that electron really doesn't want to be on the outside shell. They don't like that. They want to be as close to the nucleus as possible because that's where the positive charges are. And so once it's a high electron, sometimes it'll jump back down again all on its own. And when that happens, light is released. Now in this case, I show yellow light with that lightning bolt. But depending on how many shells it jumps either up or down, it can make different colors and different wavelengths of light. Now each atom is different, and each atom can actually make multiple wavelengths of light depending on how many shells it has and how many electrons it has. So for example, this top atom up here can release blue, blue, and violet depending on how many electrons or how many shells those electrons fell down. This one down here can release red, orange, and yellow, which are lower in energy. Maybe it has less electrons, maybe it has shells that are closer spaced together, so there's less energy released every time it falls back down. The shorter the wavelength, the higher the energy. Let's talk about emission spectra. So an emission spectra is when those electrons fall back down again and release their light. That's it. What light is released by an atom? So these electrons can release these wavelengths of light. That would be an emission spectra. For this one, it'd be a red, a yellow, purple, orange, and another yellow. Now an emission spectra emits only specific light for that atom. So only this atom will release these specific wavelengths. A different atom will never release the same as a different other atom. Now molecules can also release light. It's not just single atoms. But molecules will also only have their specific wavelengths that they can release. So for absorption spectra, you have electrons that are in their already lowest state. Now, what happens when they absorb some of the light that caused them to jump up. So instead of all this light coming through, a red, two yellows, a couple oranges, red, orange, and all these colors, the reds, yellows, and oranges are absorbed by those electrons, kicking them up. So what happens is these wavelengths of light never make it through. An absorption spectra absorbs certain wavelengths of light. Other wavelengths can go right through and are not absorbed, so they are not affected. So what you end up seeing is a rainbow missing certain wavelengths of light, and those certain wavelengths are exactly equal and opposite to the emission spectra. These wavelengths that are missing are the wavelengths that that type of atom would emit if it was energized, as you can see here.